Alright, Pilot's Handbook of Aeronautical Knowledge. This will be 9-2. This will be Weight Changes. Chapter 9, 9-2. The operating weight of an aircraft can be changed by simply altering the fuel load. Gasoline has considerable weight, 6 pounds per gallon. 30 gallons of fuel may weigh more than one passenger. If a pilot lowers airplane weight by reducing fuel, the resulting decrease in the range of the airplane must be taken into consideration during flight planning. During flight, fuel burn is normally the only weight change that takes place. As fuel is used, an aircraft becomes lighter and performance is improved. Changes of fixed equipment have a major effect upon the weight of an aircraft. The installation of extra radios or instruments, as well as repairs or modifications, may also affect the weight of an aircraft. Balance, stability, and center of gravity. Balance refers to the location of the center of gravity in an aircraft and is important to stability and safety in flight. The center of gravity is a point at which the aircraft would balance if it were suspended at that point. The primary concern in balancing an aircraft is the force and aft location of the center of gravity along the longitudinal axis. The center of gravity is not necessarily a fixed point. Its location depends on the distribution of weight in the aircraft. As variable load items are shifted or expended, there is a resultant shift in center of gravity location. The distance between the forward and back limits for the position of the center of gravity or CG range is certified for an aircraft by the manufacturer. The pilot should realize that if the CG is displaced too far forward on the longitudinal axis, a nose-heavy condition will result. Conversely, if the CG is placed too far aft on the longitudinal axis, a tail-heavy condition results. It is possible that the pilot could not control the aircraft if the CG location produced an unstable condition. Figure 9-1. I'll read through that real quick. Okay. Location of the center of gravity. With reference to the lateral axis is also important. For each item of weight existing to the left of the fuselage center line, there is an equal weight existing at the corresponding location on the right. This may be upset by an unbalanced lateral loading. The position of the lateral center of gravity is not computed in all aircraft, but the pilot must be aware that adverse effects arise as a result of laterally unbalanced condition. In an airplane, lateral unbalance occurs if the fuel load is mismanaged by supplying the engine or engines unevenly from tanks on one side of the airplane. The pilot can compensate for the resulting wing-heavy condition by adjusting the trim or by holding a constant control pressure. This action places the aircraft control in an out-of-streamline condition, increasing drag, and results in decreasing operating efficiency. Since lateral balance is addressed when needed in the Aircraft Flight Manual, AFM, a longitudinal balance is more critical. Further reference to balance in this handbook means longitudinal location of the center of gravity. A single pilot operating a small rotorcraft may require additional weight to keep the aircraft laterally balanced. Flying an aircraft that is out of balance can produce increased pilot fatigue with obvious effects on the safety and efficiency of flight. The pilot's natural correction for longitudinal unbalance is a change of trim to remove the excessive control pressure. Excessive trim, however, has the effect of reducing not only aerodynamic efficiency, but also primary control travel distance in the direction the trim is applied. Effects of adverse balance. Adverse balance conditions, we'll hold off right there. We're not going to go into effects of adverse balance. That was just balance, stability, and center of gravity, and weight changes. Yep. That was 9-2 and 9-3. See ya.